Hi, welcome to SS 7.5, Transformations. There are three kinds of transformations. Translations is one, and that is a slide. Rotations, that's number two, and that is a turn. And reflections, number three, that's a flip. Look it in the mirror. And we're only talking here about, these are just 2D shapes, so on a flat plane, the Cartesian plane. And we're using all four quadrants. So before you might have done transformations, but only in quadrant 1. Now we're using quadrant 2, 3, and 4. So indicators for this outcome, you need to identify your coordinates, so your ordered pair of the vertices, which are the pointy parts. So a triangle has 3 vertices. When you're only talking about one, like an angle, it's called a vertex. When you're talking about more than one, it's vertices, that's the plural. Describing the movement. So we have a slide coming up all about the movement. How is it getting from point A to point B? And again, what is the new position of these vertices? And we talk about the image versus the shape, and I will explain that in a minute. Determining the distance between the points. So just like on a map, how far did it travel and in what direction? Actually performing the transformations and identifying the new coordinates for the image, and talking about the positional change, where and how did it go. And the last one, describe the image, which means the new shape after the move. Alright, so just a quick review. Remember when you're plotting points that you do your x-axis first, and so Mario style, he's going to run along the x-axis and then he's going to jump. That's the y-axis. So we're always plotting x first and then y. So x is horizontal and then y is your vertical. Or as Noah explained to me one day, you have to go in the house, so that's your x-axis, and then up the stairs. That's your y-axis. You cannot just go to someone's house and start climbing their stairs from the outside. You have to go in the house first. So in the house, then up the stairs. This original shape, we'll call this ABC. Okay, so the green shape is my original shape. So on the orange shape, this was a rotation, and they pinned it at point C. So you would say it's a rotation about point C. Is it going counterclockwise or clockwise? Okay, so it's going clockwise. And how many degrees? Well, if they took this original line from B to C, it was going horizontal along this line, and now it's going straight up and down. So they rotated it clockwise 90 degrees. The gray shape was a translation. It was a slide. So let's take this point here, and the new point ended up over here, the image. So if this was A, this is now A1. And so how did they move the green shape to turn it into the image, the gray shape? Well, let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So they moved it 10 to the right, and then 1, 2, 3, 4, 5, 6 down. So they took that whole shape and moved it 10 to the right and 6 down. And you can tell that just by finding one point and comparing the shape with the image. You've probably seen this before where the original shape, let's look up here for a second, the original shape is triangle ABC, the blue guy. And you'll see that they've labeled this as point A and it's at 2, 1. And then when they moved it, it's no longer called A, it's called A1 because this was the shape, and then after they moved it, this is the image. And so to keep it straight, they label it a little bit differently with the little tiny 1 in superscript. Okay, so back down to our diagram in the bottom. How did they get the green to turn into the blue? So this was a reflection, and the line of reflection was the x-axis. And so this original shape was 1 space away from the x-axis, so then they had to go 1 space away underneath as well. And it's just a flip, like looking in the mirror, and the x-axis is that line of symmetry. So how can you describe what happened to the shape to turn it into the image? So you have to be able to describe the coordinates of your shape and then the coordinates of the image. And then what did they use to get there? Was it a rotation, a translation, or a reflection? So if it was a rotation, was it rotated on the point? Or maybe it was, or sorry, that's a vertex right there. That's a vertex. Or maybe it was rotated around the point. And so a point on a graph, let's see. Imagine a piece of string holding this point to the origin, and we're going to swing that string around and put our new shape there. And so it's still connected to the string, it's just moved. So around the point. How many degrees did it go? So you would measure your degrees and say, well, it moved, looks like maybe 50 degrees. And in what direction? So in this case, we went clockwise. So there's a lot going on with a rotation. In a translation, you just need to know the direction, up, down, left, or right, and the number of spaces. And in a reflection, you just need to know over what line. Was it the y-axis? Was it the x-axis? Or sometimes they'll give you a horizontal or a diagonal line, and you can reflect your shape over a diagonal. This is a recording from mathwarehouse.com, and so you can see that they have a transformation going on. Here is the original shape, and here is the first image, and then they've got the second image. Notice the 2 little tick marks. So the shape is called A, the second image is called A1, and then we have A2. So every time you move an image and give it a new location, you have to call it something else, not the original shape. So in this case, it looks like they've rotated triangle ABC around the origin. Okay, I'm just going to scroll down. So mathwarehouse.com explains a transformation as there's 4 specific ways to manipulate a shape. We only talk about 3, so you'll see dilation down here as their 4th one. If you want to check into it and see what that is, let me know, because I don't actually know what that is either. I would imagine dilation has something to do with making something smaller or larger, so we'll see if I'm right. Anyways, they also call the original shape of the object the pre-image. We don't necessarily call it pre-image, we would just call it shape. And then the next one is called the image. So types of transformations, we're going to talk about translation, reflection, and rotation. So in this example, they are translating. This is a slide. So they've taken the original shape and slid it over. And so when you're talking about translations, you want to tell us how far you're translating that shape. And so if you wanted to talk about this point, negative 5, 1, they've moved it 1, 2, 3, 4, 5, 6 spaces to the right. So this shape was translated 6 spaces to the right, and then once it arrived there, they called it the image, and they took that image and they moved it over and down. So it was translated 1 more space to the right and however many spaces down. 1, 2, 3, 4, 5, 6, 7, 7 spaces down. Okay, moving on. Let's go back up here. We can hit reflection. So this is going to be a reflection on the x-axis, and they just reflected a point. They called this point A, and they reflected it upon the x-axis. So imagine they folded their paper in half on the x-axis, and this is where the matching point would be. So it's one space away from the x-axis. Reflecting on the y-axis, fold your paper in half down the y-axis, and here's the original shape A, or the original point A. It is 2 spaces away from the y-axis, so then the image has to be 2 spaces away. Most of the time we reflect on a line, and I think in grade 7 you do both reflections on the x-axis and on the y-axis. So they've given us actually a diagonal line to reflect on and said reflect point A on this line. And so forget about your axes for just a minute and think about this line. Fold your paper there and see where your new A would end up. Okay. So now they're folding this one, it's a reflection on the y-axis, so they've taken this purple shape and called the image a reflection over here, and then they reflected it over the x-axis, so this was 2 reflections. Okay, going back up to the top, let's have a look at a rotation. So when you talk about rotations, did you notice that it said it has to be 90 degrees? So rotation always has the direction that you're rotating something and the number of degrees. So they would say counterclockwise 180 degrees. Now they're going to rotate 270 degrees, again counterclockwise. So they took that original point, swiveled it around, and made it a new home. So just imagine that a triangle was attached to that. Or in this case we have 2 lines. So this one says rotate 90 degrees about the origin. So stick a pin right in the origin, and that's where that point has to stay, but your A is going to swing 90 degrees. Now this one doesn't say counterclockwise, but that's obviously what they did. So when you're talking about rotations, you want to talk about degrees and direction.